Hello. Hopefully we'll have better internet weather today. Internet weather. We're going to take a couple minutes just to let people come along. I'll pause my video streams. Looks like we're going. Good afternoon, David. Good afternoon. Well, morning for Unexpected Maker. Evening for Johnny, I think. And hello, Michael. I've got a lot of like sunshine on me today. I think I'm going to go for a run after the stream and get some exercise. It'll be good. I really want to try to run twice a week. It's hard to find the time. Hello, Dishipu. Hello, Dave. I tidied my workspace. I kind of did. Not since the last stream, though. I now have a shelf over here, too, that has been... I had a bunch of stuff on the floor, so I at least, like, literally just, like, took the things that were on the floor and put them on the shelf over there, so... It's been worse. This is kind of how my brain operates anyway, let's be real. Like, I have all sorts of things in my mind and brain and that I'm working on, so yeah. Beata says, sleepy morning. Dentist went well Monday, but it's still going well. Oh, sleepy morning. Hi, Ali Khan from Kazakhstan. Hopefully I said it okay. All right, let's get going. Hello, everyone. My name is Scott. I work on CircuitPython for Adafruit. Hi, Tim from Woodland, California. We don't take ourselves too seriously, or I don't take myself very seriously during this stream. If you don't know, Adafruit is an open source hardware and software company based out in New York City. If you want to support me and or them, I work for them. You can go to adafruit.com, purchase some stuff there. I work remotely for them, and I have for, 7 years now, which is kind of wild. And I work on CircuitPython. So CircuitPython is a version of Python, which is a programming language designed to be easy for beginners and really fast to iterate on microcontrollers. And microcontrollers are little tiny computers. Here's a good one, actually. Like this chip here is an Espressif ESP32S3, and it can do things like drive a display like this. So microcontrollers are really tiny computers, and they're great at doing one thing, and you can have lots of them doing single tasks. So, and they're commonly used to drive displays and read sensors and things like that. So CircuitPython its goal is to make it easy for people to use. Now, this is a deep dive, and deep dives are, and I just realized I can click into the eye tracking focus. I'll say hi to, yeah, I guess Johnny and Dave I said hi to, and Beata I said hi to as well. And Tyeth is in the Discord chat as well. Oh, Discord. Up here is the Discord chat. I recommend it because it doesn't disappear at the end of the stream. If you want to join it, you're just on YouTube and you want to do that, it's the URL adafru.it/discord. That'll get you into the Discord chat there. Dishipu is asking about pronunciation. I thought it was Beata like Miata, but I don't know. I'm sorry if I've been saying it wrong. Beata. And feel free to correct me. What else was I going to say? So deep dive. Tangents are welcome. So questions. If you have questions about CircuitPython, embedded, anything I can help with, feel free to ask them in the YouTube chat or the Discord chat. I do have kind of an aggregate of the Twitch chat as well, so I should see those. Twitch and LinkedIn, I think, do come in as well. So if you have questions, feel free to ask those. I'm happy to try and answer them. I make no promises about my ability to answer them. But yeah, so hi Super Ryu, welcome. The other bit of housekeeping. Hi Crystal Monolith, welcome to you as well. So CircuitPython 2024 wrapped up this week. I drafted the post and intended on pushing it out yesterday, and then I was looking through my tabs this morning realizing I hadn't actually posted it. So CircuitPython hashtag the year, or hashtag CircuitPython the year, is our kind of annual planning where we're trying to kind of come up with a community plan for what we want to get going, what we want to do in the coming year. It's a great way to see like bigger picture stuff from folks. And we ran that all through January, although most of our participation was at the end. And we got a bunch of different responses. So maybe I'll just go, this is kind of like a brief summary. Tyeth said on Wednesday, wanting support for the parallel display and this board here. The reason I have this is I was testing it, and it's got, the display is connected in parallel, so there's like 8-bit signals, so it's an 8-bit bus, which is more than like a normal SPI bus is. So I was getting that working on the ESP32S3, and then they also requested long-range Wi-Fi in the ESP, which I don't know much about, but yeah, now I've heard of it. Toddbot had wanted dynamically loaded native modules. Those are really tricky, and he says it would not be easy. So I would say that's probably not going to happen. I understand the reasoning. So Toddbot's reasoning is that we don't have to worry about flash space as much if we're able to load native code when we need it. Some Nice had requested something to make disks not ejected properly warnings don't happen as much. And I suggest looking up above in the live broadcast chat. Toddbot had a suggestion. Subaru says, don't have 16-bit parallel, it's faster. I think 16-bit will work, but the hardware that I have to test with is 8-bit parallel. So yeah. Let's see, what else? SL0 asked and hoped for being able to easily test their code. Dexter emailed wanting or saying they're interested in Plan 9 style synthetic file systems and ferroelectric RAM. Sanka wrote a blog post, kind of a tutorial about the TM1637 LED driver. John Hyde was interested in IP over USB. Jeff talked about supporting things like USB host and really documenting them so people actually use them. And then actually also talked about, maybe it's time that we stop supporting certain boards so that we don't have to worry about code size so much. Some of the SAMD21s are really full, and he kind of posed the question of like, should we declare like CircuitPython 9 being the last one for those boards? And I think my answer is no. It's a huge pain to keep them up to date, but like I think it'll be more pain if we have to say like you can't use new code on the old boards. Mark, who goes by Gambler on Discord as well, was interested in like picking up some tasks that weren't high priority for Adafruit funded folks, but sounded interesting to them. I think Synth.io and some graphics display IO stuff was on his radar. And then just continuing to hang out and be helpful. Liz talked about increasing their involvement in CircuitPython, including writing libraries, and also like, I think straight up saying like she wanted to help me document features as I add them so that people actually know about them and can use them, which is awesome. And I think somewhat of what came into my CircuitPython 2024 as well. And wrote on X a wish list which centers around interoperability with old IBM PCs, including the idea the idea of running CircuitPython or MicroPython from within, like on the PCs themselves, which I actually mentioned to Jim, who works on MicroPython, and he said they actually they had a FreeDOS port that they removed. So it's possible, I guess. Wave Sailor posted on the forum particularly about wanting a reference card for migrating between MicroPython and CircuitPython, which I think is an interesting idea and something that we could do better. Like, somebody had pointed me to Arduino. Yeah, the Arduino language reference. So like, this is a really handy page for Arduino folks, and we don't have kind of an equivalent for CircuitPython, which could be potentially really useful. But then, you know, there's overlap between like what a SAMD or what a Python reference would include and like a CircuitPython reference would include. I talked about in my post mostly about the BLE workflow and the kind of USB host workflow where you have a display and you have a keyboard all plugged in. Like even Foamy Guy, who's like plays pretty good attention, didn't understand that if you plugged a keyboard in with USB host active, it would like automatically convert it into characters for you. Incredible Littleby on the forums wanted some Blinka MotorKit support stuff, and the first person was DJ Devon3, who had thoughts about supporting more displays and the ESP32S3. So that's kind of a quick recap of CircuitPython 24. All these links here are links to the like full posts, and if this is interesting to you, I'd encourage you to click through and read all about it. Beata says, I would like Seesaw on the SAMD21. Had been inactive. This heart is right over like the last word in the line. Had been inactive for a while, so I went on to other projects. I don't know what you mean by Seesaw on SAMD21. Because you should be able to use I2C to talk to a Seesaw device. But maybe that doesn't, maybe the library is too big? I don't know. Mark had said, would be interesting to know the sales on the SAMD21 stuff. It's hard to know. I mean, I used to have access to the charts, but the last couple of years have been really screwed up by just availability. And I think we sold a lot of SAMD21s, and like we still sell like Circuit Playground Expresses or SAMD21s. I don't think it's time yet. We're just gonna have to deal with it. David says, I don't see my CircuitPython 2024 post. Did you email me? Did you email it to CircuitPython 2021? Oh, it's 2021. 2024. I might have missed it. Sorry. Email me and I'll add it. I can edit this post, so it's in there. Taya says, I prefer to have features turned off than drop support for the boards. Ideally, still turn onable, maybe a simple CI workflow that allows toggling some build options and feature flags. So the simple CI workflow exists. Microdev added it. I don't think anybody uses it. But yeah, that's generally our approach, is that, you know, we partition most of our functionality by module, and they're easy to turn off and on. And so new modules just don't end up in the SAMD21 build. Now, that's not entirely true for like, I ran out of space when I changed the way storage.mount worked, right? And that's something that's already in the SAMD21. So it's not super simple, but yeah. Unexpected Maker says, I also think maybe 9 should be long-term support version than the last for flash constrained boards. I mean, we're always gonna have flash constrained boards though. Like there's even like the ESP32S3s with the like 4 megs flash. Like we have a smaller partition for CircuitPython than on the bigger flash chips, and we're like running out of space there too. Like it's gonna happen. Yeah, and Mark points out that changing existing stuff is... Oh, it was on X. I'm not on X anymore. Sorry. But yes, I will add it, and I will open it in Open up my browser. Let's look. Let's live review David's post here. Not doing a lot of CircuitPython projects right now. Been doing Neo retro computing, Home Assistant, a NUC as a NAS, and NVIDIA Shield as Plex, and building a home lab server. So that's distracted away from CircuitPython. But I still have CircuitPython dreams, ideas for the future, and suggestions. Adafruit, let's build a random list of 9 ideas. Okay, number 1, CircuitPython first. There are a few Adafruit boards, sensors that do not have support in CircuitPython. I keep acquiring these by mistake with the secret hope of future support in CircuitPython, but Adafruit should force themselves not to release a product until it's clear that support in CircuitPython is guaranteed to be possible in the short or medium term. That's a good point. I know one example is the USB host. The USB host Featherwing is not supported, and that's been my intention, but as you know, my life kind of got clobbered by some family personal stuff, so did not happen. But yeah, if you have a list, feel free to open issues on CircuitPython. We do have a libraries milestone, so we can track it there, and generally we do want everything that's Adafruit releases to be supported in CircuitPython, so feel free to bug us about those. Support for the Raspberry RP2040 successor is written in the stars. Raspberry Pi is working on an evolved version of the RP2040 microcontroller. Maybe it'll have more cores, more memory, more storage, or whatnot. Adafruit should be in the starting block as soon as they have access to hardware. CP support should be better and more user-friendly than what NP can offer. Hopefully. Hopefully. I will tell you, I did have the RP2040 a little bit before it was announced. So my hope is that the Raspberry Pi folks will give us a heads up as well, so that we'll be able to support it when and if it comes. Let's see. I'm sure I'll have migrated to Wayland before everyone has been comfortable being on X. I moved my laptop to Wayland, and it's been okay. Okay, let's go down this list. I'm liking it so far, and we're through 2 of 9. So 3, excellent Bluetooth support. It's near perfect on NRF, but it's limited on the S3 and the PicoW. Be great to bring all platforms to the same level. I agree, especially for ESP32S3. I have a love-hate relationship with the external chip on the PicoW, so S3 is far more interesting to me and kind of pretty high on my list, so I'd like to do that. Oh, number 4, this is a theme too. More marketing for the software features. Yeah. But if it's not from an individual or not linked to a new product, the feature might go totally under the radar. Yeah. And I'll tell you, I do feel like a little bit like we're actually a bit backlogged. So like we have features that we've done for future products that just haven't been released yet. So you might see, yeah, this will come. Better indexing of the CircuitPython YouTube content. There are a lot of episodes of CircuitPython Parsec, Product Pick of the Week, or other. But over time, they become harder to find as there are no searchable index of the episodes. They should be listed somewhere so that newcomers can find them and others can find them again and revisit them. Yeah. Do we even have an index of all the great CircuitPython Parsec and all the presentations and show and tell? I would check the playlists. I know that when I do deep dives, I add them to the deep dive playlist, so they are at least separated on YouTube in that way. Hi Fede2. Maybe a series when 9.0 is released showing more details about the new features. Yeah, that's a good idea. We should do that. We could have a video about 9.0. A lot of the changes are internal, but one thing I So we just changed the storage.mount behavior, and a lot of folks are hitting that. So one thing I want to do with the next release, the next beta release, and Dan does basically all the releases now. And he's back next week. So I think we need to split out, like there's all the new features on 9.0. We actually need to say breaking changes separate from all of the changes. Let's see, improve USB host support. Yeah, more learn guides. So Foamy Guy is actively working on a learn guide for USB hosts. So that is kind of an avenue we're hoping to send Foamy Guy down is the USB host rabbit hole and get some really good learn guides. And as he does the learn guides, he'll test it and find issues as well. The support cannot be limited to one board. We need the Featherwing first class too. Yeah, I know. I know. Sorry, that it was on my radar. Like I got one early, and the support is in Tiny USB. It was on my radar, and I just lost a bunch of time to my family stuff. So it's on my radar too. I want to get 9.0 out the door. Like that's an example of something that we can do after 9.0 is stable. And there's a lot of good stuff in 9.0, and like when people have issues, we're just like use 9.0. So like 9.0 is kind of like what I'm really trying to be laser focused on. Now, the work that I've been doing the last couple of days is not super laser focused, but it's still good. Still good work to do. We'll get into that. 7, create and support products with multiple CPUs. The quest for a CircuitPython computer seems difficult if attempted on a single MCU. Would be more easy having multiple RP2040s or other boards collaborating to produce a result. Yeah, I really like multiple MCU stuff is really hard. But then again, I've always had this idea of the stemma G0, which is like a different STM32 over stemma sort of thing. And yeah. Unified network stack. Today doing network with, it's different depending on Airlift, ESP32 or WizNet, or native. Or yeah, ESP30, yeah, Airlift, right? Yeah, ESP32 SPI. Yeah. Yeah, this is definitely an area where I'm not like super like got it all right that I want to do. 9, Stranger Things over USB. CircuitPython can already do a lot of USB. Pretending to be a network adapter representing USB mass storage independent from CircuitPy. Pretending to be a Milkv printer sound card. Yeah, so Jeff is working on video, so it's that's merged in, and I think it might be after beta 0 as well. But Jeff did merge in the ability to have a frame buffer that is rendered to from display I/O that then the video goes up the USB link, which is cool. I think we should do audio too, but audio is also complicated. Network adapter is like something that John Hind pointed out, but I don't know what that involves, and it's not super interesting to me. Presenting a USB mass storage independent from CircuitPy, that is, yeah, some work that we spent for a while, and then it got stalled out. It got stalled out because different operating systems were like having different issues. Like it's kind of weird. Yeah, the mass storage thing is like it has a concept of logical units or LUNs, and we were trying to have multiple LUNs support it, and those are, yeah, they work differently on different OSs, and so that's been kind of tricky. We don't have a great solution for that, unfortunately. Fede2 says, I have in the mail 10 USB host feathers for making hidden remappers that will be used to test the Costa Rica keyboard. Nice. Yeah, those should work. It's the feather wings that we don't have CircuitPython support yet. Someone is already working on it. Mark says, I was having lots of fun with the USB HID stuff lately. Got some new encoders from DigiKey to do more with it. Writing custom USB descriptors is a bit less fun. My hope with custom USB descriptors is that we could have libraries for doing more oddball stuff. So like you write it once and then hopefully we can share it afterwards. Jonathan Rodriguez says FAT32. I'm not exactly sure what you mean by that, but we do support FAT32. In our, like the library we use supports FAT32 and exFAT as well. On some boards. I think on the small boards we limit it, but on all the new stuff it's there. Okay, I'm gonna stash this tab back down in my off-screen browser. I really think that I'm really interested in doing the IMX1060 on an Adafruit boards or multiple Adafruit boards because it has dual USB. So there's a lot of stuff that you could do that is kind of like you could do host natively, which would be nice. Mark says, if time and brainpower permits, I may write up a quick tutorial. There's a tool to help you write the descriptors from TOML files. Okay, so that was CircuitPython 2024. I'll also note one project that I've been doing is I've been digging into llvm a little bit. So if you don't know what llvm is, it's a project for compiler tools, and the like C front end is called Clang, and there's a linker called LLD. And there's this problem that we hit a lot, which is parts like the ESP32s, the RP2040s, and the IMX chips, they all store the bulk of the code on an external flash chip. And then they have a cache in front that makes it faster, basically. And because we store CircuitPy on that same flash chip, there are times where code's not available. And so what you can do is you take all the code that needs to run when that is happening and you put it in RAM so that you can run it still. But it's really, really prone to getting it wrong because anything that function calls also needs to be put in RAM, otherwise it'll crash. And there's no good way of knowing that. So I've been prototyping a feature to LLVM that allows us to set an attribute on a function, and the compiler and linker will work together to make sure that everything this function uses ends up in the RAM with it. So I've been dabbling in that. That's been something I need to get back to. It's been a couple days, but I think it's kind of a killer feature, especially as I suspect that a lot of the new chips will have that as well. Hi, James. Welcome. Let's see. Johnny says, I would add that the Adafruit Arduino libraries would need some love as well. There are loads of pull requests that are years old already. I had to fix 2 bugs in one library when developing the JB Whopper library, but there isn't even a Discord channel for that. Besides help with Arduino, I don't think we really have, like Lamore is kind of the person that maintains the Arduino libraries. I don't think we currently have anybody else. I know TAC does some of them, but yeah. I definitely do not. That is outside my boundary of what I do. David says, I think it's possible to do USB hid and provide a web interface that works on Chrome to control your board, but imagine a web server running on your MCU and accessing it via browser over USB without WizNet or Wi-Fi. Yeah, that sounds like John Hine posted to that as well, of like IP over USB. Yeah. Fede2 says there's a new version of the Milkv-duo, still 700 megahertz core plus a gigahertz core. And the new one, you can run Arduino on the slow one and Linux on the fast one. And again, way faster and cheaper than IMX6 chips. But the ones from Milkv don't have Bluetooth or Wi-Fi. That'd have to be a separate chip. I'd be curious, has anybody gotten Tiny USB running on those already? It depends on what the USB IP is, but that would be a prerequisite to bringing CircuitPython to it, is having Tiny USB support. So consider that your challenge if you want to see CircuitPython running on it. I think that's it. Are there any questions before I change topics again? Maybe I'll look at these. I'd love to get to the part of the other reason I'm interested in the Clang stuff is like code size is really important for us, and I'd love to be able to like hack the compiler to figure out if I can actually make code size smaller, which is like super nerdy of me, but yeah, I'm interested in that. Starting from $5. Architecture, video subsystem, boot select. What is the SG202? Milkv-duo has Ethernet. HID remapper uses webhead and it's a very nice interface. You download the XML from the board from the web interface, and every change you make is very fast to send to the board. HID remapper would be really interesting to figure out how to do that from CircuitPython. Like ideally with a custom USB descriptor, you could probably do that. David says he's been using it too. Or do you need to get a separate board with the Ethernet inductors? So what are these different... all chip data is open source. Interesting that the RP2040 is like their main competition. Duo S. Oh, and it's got an ARM A53 in it too. USB. Type-C for power and data, or one USB 2.0 port, host port. What is this chip? Storage. In package DRAM. Body control. Micro semi. Do they make the chip themselves? In-house TPU. Boot select. Does this mean you run the RISC-V core or the A53? ARM core and the RISC-V core are exclusive. You decide what you want to use at the boost process. That's kind of weird. A53. Interesting. Huh. USB 2. MCU subsystem. That's separate from the CPU system. But the MCU system does not have USB. I know that the A series is like harder to run on, for sure. So maybe this, I don't know this RISC-V core either, so I don't know. That's the other thing about Clang is, yeah, that's what I would use for RISC-V too. Sophon.ai makes the chips. The 2042. It's all about LLM. TPU processors, RISC-V processors. They only have one processor listed here, but maybe the ones in the Milkv are all the ones they're done with. 2 gigahertz. PCIe, wow. Huh. All right, enough dev board shopping. Although I do love pulling up the DigiKey new dev boards page. I don't see any questions, so let's move on. So the title I called for this video is the CircuitPython Implementers Guide. And so I kind of want to commit myself to finishing this guide. I literally started it a year ago. But Lamore had asked me, suppose somebody comes to us and says, hey, we want to add our chip family support, right, to CircuitPython. What do I need to know, right? So what do I need to know from a developer's perspective? And this is kind of what Deep Dive does too, but like a guide form of that. So I kind of wanted to tell people I'm working on this, or I had worked on it, and the work that I was doing is there was issues, there was a crash. How did I get down this rabbit hole? There's an issue. So I'm trying to get all of the 9.0 issues out of the way. There's still 39 of them, which is unfortunate. But there's one assigned to me. For some of these, I have PRs out already for. Like the parallel bus one, Jeff's out the rest, starting the end of this week. Dan's out all this week. So I'm quite backlogged on PRs that I have out that haven't gotten reviewed yet. And maybe we should just go over those. But the thing that started us all, there's a guide for adding a board. Now you want a guide to add a family. Yes, yeah, that's the basic idea. So there's this bug where FrequencyIn is causing crashes. And as MicroDev pointed out, that the P count peripheral is a pulse counter peripheral, and GP timer stuff, they're deprecated in IDF 5, which is what we moved to. So I kind of said, screw it, I'll just update to the new drivers. Because actually, as I've been doing this, I realized the new drivers in ESP5 are much nicer than the ones in 4. There's a reason. The reason they had good reason to redo them. They're much nicer now. So, and when you migrate over, you have to switch all the places to the new driver. One of the things that has been really nice in the new drivers is that the new drivers in the IDF keep track of who's using what resource. So that's something CircuitPython's done already of on SAMD21 and you want I2C, which, hi Hams Labs, which Circom goes with what pins sort of thing. And the ESP has more flexibility for wires, but they still have finite resources. So the ESP-IDF and 5 and these new drivers, they track all of that resource usage for us, which is really awesome. So in general, these APIs have been improved, but when we switched them over, we were getting in main right now, there's 3 warnings we're getting. We're getting GP timer or timer, we're getting P count warnings, and then lastly we're getting an RMT warning, which is a remote control peripheral sort of thing. So there's this crash for FrequencyIn that's marked as 9.0, and I was like, I'll fix this by just switching over to the new driver. And it looks like what was happening is that, and I was talking about this earlier, where if you're writing Flash, you can't access the Flash, and you need to make sure that all the code that you run while the Flash is disabled is in RAM. And furthermore, it's not just the code that's running, but it's all the data that it needs as well. And when you're writing Flash, the cache that is on ESP, the cache that's in front of Flash and RAM is shared between Flash and RAM. So you not only, when you're writing or when you're erasing or writing Flash, you lose access to PSRAM as well as the Flash. So I think the cause of this FrequencyIn crash is that the way FrequencyIn works is that it sets a timer, says, hey, every however many milliseconds, call me back. We'll see how many pulses we counted, and we'll figure out their frequency from there. And that runs kind of freewheeling, so that in Python, all you see is .frequency, and it changes over time. So what has happened is that, if I run this code, and then I try to write code.pile again while it's running, which is a Flash write, a erase and then a write, I might cause a crash. And so that's what was happening is that even though the function callback was marked for RAM, it was trying to access the CircuitPython the CircuitPython FrequencyIn object, which is in PSRAM and not actually available. Anyway, so I decided to redo FrequencyIn to upgrade it to the new API. Turns out that count.io and rotary.io also use this p-count driver, the pulse count driver. So I've updated those two as well. And then since I upgraded to the new timer one and the new pulse count driver, I was just like, screw it, I'll just do the RMT one as well. So the RMT one is it's a remote control peripheral, and it's used for Neopixel, pulseIn, and pulseOut, which are in the pulseIO modules. So I've been redoing all of the code for these 5 modules: pulseIO, Neopixel write, rotary.io, frequency.io, and count.io are all going to be new implementations, basically. So yeah, I'm in the middle of getting that all working. And then what I realized is that I had this old Learn guide that I had started, where the idea is that there's general tips and tricks about implementing CircuitPython, and then kind of per module notes, and in particular per module testing. So I was like, let me dust this off. So for frequency.io, here's a link to the documentation, and oh, by the way, here's the test code that I was using to test it. You can see that I've added a pulseIO one, because that's kind of the next stuff that I'm working on. So I've actually, I've updated count.io and rotary.io, but I haven't tested it yet. So I'll go back to these things and edit those. Okay, I see a question from David, who asks, who wrote the Spresense support? Is it you, or is it people from Sony, or did they know how to add an MCU family to CircuitPython? So it was folks from Sony, or at least one person, the CamTom 480 person works for Sony, I believe. And yeah, they did add the MCU support. They figured it out on their own. It's the structure of CircuitPython lends itself well to being able to do it, because we have the shared bindings factored out, and then it's all just C functions. But there's a lot of kind of behavior that's not well documented, potentially, that or caveats that need to be kind of called out, that this guide is going to do too. And then the other port that was done by manufacturer is the SciLabs port. So credit to SciLabs as well. They added the support for their chips into CircuitPython all on their own, basically. And they do support it. They've been pretty active, like fixing stuff that's come up, especially in like the Bluetooth land, which has been awesome. So let's just, I like brain dumped this over 3 days. The other thing that I kind of need to, kind of one of the reasons I want to release is because I've actually cited some of these charts. So last year I worked on performance for the IMX because the pitch with the IMX parts is that they're really fast. I talk about it here, and I measured some stuff, so you can actually see like these numbers are from whenever I worked on this, and I should definitely call those out. But you can see like the different blink speeds that you can get with this basic blink test. And then, oh yeah, so March of last year is when they were, so good, I marked that down. And then there's also performance benchmarks that we have inherited from MicroPython. And this is for 8, so I'll have to update these. But there is actually like some performance numbers that I took at the time as well. Would Adafruit or Freelance offer add a new board as a service or add a new MCU as a service? I don't know if we do add a new board as a service, because generally like Adafruit making like a new board def is really not that hard. Adding a new MCU as a service is kind of, it's not explicitly done, but it is done through a like we put our effort towards the MCUs that we know we're gonna have products on, and some of our products can be influenced by like pricing deals that potentially Adafruit can get. So it's not direct, but yeah, like there is ways to influence the MCUs that we're gonna add. Let's just go back and see how much I wrote into the overview. Okay, so this is talking about, yeah, and this is when I was doing all the PySigrok stuff. So it's using the Pico Sigrok things. These are gotchas. Resource usage tracking, code structure, MicroPython basics, arguments, exceptions, getting started on a module, port reset, never reset. Like I said, this is kind of like, I need to get this. I need to publish this because I really like wrote a lot of stuff about it. So it like it has test cases and like talks about things that were. Do you have sleep/alarm in my list? I don't. That's a good request though. But I think this is part of the problem, and I need to figure out a minimal set of things to do. Is because like there's valuable stuff in here and I shouldn't wait till I've written it all. Like instead I can upgrade it or update it over time. But I think what I will do is like I'll add alarm into here. Because you're right. And we'll probably do some work on that later this year too. Correct, this guide is not public yet. Although I think I might be able to. if I send you this link, I think I can send preview links even though it's not public yet. Maybe you should write a list of priorities and features that can be done software bit bang and implement later in the kernel. Yeah, so that is, this left-hand side is definitely like, it is trying to do it in order that you should implement them. Because I talk about like, you have to do, once you do bus IO, you can do display IO and things like that. And I didn't do the bus IO testing yet. Maybe I did, but I'm starting to work on it. I have to go back and do more of the testing stuff. Yeah. Like some of these are just empty placeholders, like rotary IO. But so I'm redoing the rotary IO implementation on the ESP, and that gives me a chance to circle back here. I was reading through some of the issues for pulseIn, and there's a lot of them. So there's like definitely cases where we like need to better specify the behavior and then make sure that all the ports fit that behavior. So like our APIs are more uniform because at the Python level, but there's nothing really stopping the implementations from varying under the hood in terms of like some details. So that's kind of like, those are kind of what we want to capture. Are there dependencies like to do ABCIO, you need XYZIO? Yeah, sometimes, right? Like, so display IO depends on digital in out, for example, to do like chip select lines, and PWM to do backlight brightness. So yeah, they're not completely independent. But yeah, as I'm doing these other ones, then I kind of have to do that too. So like Neopixel write, I think I wrote all the way down. Blinky test. And pictures and stuff. And then I kind of say like, once Neopixel write works, boards can set MicroPi hardware Neopixel and MP-config board to the pin object can use to do it, and then like CircuitPython will use it natively. The PWM and display IO is optional. I think it's optional, but do we have it pound to find out so it works if you don't have it implemented? I'm not sure. I don't know. It should be done earlier than pulseIO. pulseIO is complicated too. I was just doing pulseIn. I'm like, oh my goodness. pulseIn is a little complicated. All right, well, yeah, so I'm gonna, this is, like Lamore has mentioned recently that I should get back to finishing this guide. And I can, like right now, all of these pages are not published, but it is also possible in Learn to have, like, I can have more under here that I haven't done yet once like the core is done. But like bus IO is not completely done, and I've been meaning to actually like do some proper testing on bus IO. If you are a person that loves to do detailed testing stuff, like basic scripts for doing functional testing, and you want to help me, because it is not a strong suit of mine, just ping me on Discord, and I think if you have a Learn account, then I can share like authorship with you. And maybe that's what I should do, is I should talk with Carter, because Carter's really thorough about this sort of stuff too, like kind of collaborating on it. Because obviously, like doing it by myself, I like got really into it for a few days and then I lost steam. But I also think that like with the work that I'm doing right now, where I'm changing the implementation on ESP, like I'm thinking about details, and that's a good time to come back to this. So with that, let's get compiling. Sorry for the car sounds. My window is open. So I did just do a restart, so I'm gonna get my IDF set up. Looks like that works. So make board Adafruit. I have an S2 here. And I actually do have the overhead if we get to testing anything. I did test FrequencyIO. And so I know that's working. But I was like doing the RMT updates. That's where I left off. I'm just updating it all. So basically I'm updating it all and then I'll go back and test it. I'll get it compiling because compiling is a good way to know what you have to update. So it shouldn't, yeah, I should have lots of errors. I haven't updated pulseOut yet. I've done Neopixel write, I did pulseIn, and pulseOut shouldn't be as hard as pulseIn because I've already done the RMT transmit stuff once. Oh, I don't even have my editor open because I updated my computer to hopefully, like, you know, I was having this frame dropping last week and I didn't know if I'd updated it at all. So I updated the computer and then I like deleted the wrong package and it didn't boot up, so it took me longer to get back into it. Luckily I did it with enough time to like fix it before the stream started. So I was on time, but I did cut it a little close. Okay, so we are in, and maybe I should set it up. It might be more worthwhile. I do have a way of let me think for a second. Project. Build system. Yeah, okay. All right. I was considering using the built-in builder, but I'm not going to do that. All right, so pulseOut. I haven't converted anything, so it really is going to be a matter of switching between, we'll just start with Neopixel write and then we'll pull up the pulseOut source. So we want pulseOut and we want Neopixel write. In fact, maybe we should, bye Dave, sleep well. Thanks for stopping by. So let's just go update pulseOut. I really like, I wish I could go hit a back button. I wish there was a back button here. Port, background, Neopixel write. Okay, so they're next to each other now. So there was this peripherals.rmt.c that Microdev added, I think, or maybe Lucian did. But basically, with IDF4, we had to do all the resource tracking ourselves and do resetting. But one thing that I wanted to do is, like, you can, when you allocate Python objects, you can say whether they have a finalizer. And so I'm moving more things to having finalizers so that we don't have to do bulk resetting. We just, when you initialize something, when you construct an object, it always will have dinit called and revert back, even if that happens when the VM is done. The original approach we took is like, kind of like, we set everything up and then it can be torn down, but if it's not torn down when the VM is done, we'll just blanket reset everything. And that's just not super easy to reason about. There's a lot of tracking you have to do that sort of bulk reset. That's part of the reason there's never reset, which actually, I guess if we completely got off that, we could actually get away with it, not doing it. We'd risk leaking stuff, but the new APIs on Espressif, they are doing memory allocations under the hood, so it's really important to kind of like construct or create and delete things as you need them. So that's, and they have these opaque handles. So actually, let's copy this whole thing. So now, here's an example of what we revert or replace. So previously, we had this find and reserve RMT thing. And now that kind of gets done under the hood in the IDF by this new TX channel. And in fact, we don't want, well, did I switch it already? Yes, I did. So we're gonna have it stored in self channel. Neopixel's a funny case. And then it's just going to be pin number that it takes in. And then we haven't set up the carrier yet, but there is this clock divider, which is super... Here's an example of how the IDF API has gotten much better. So where previously you got a clock divider and you wouldn't know... Clock divider doesn't tell you what clock it's running at because it's just a division of some clock that they're not telling you about. So the new one says, what do you want your resolution in hertz to be, which is quite nice. So clock divider 80, I was thinking it might have been, maybe this tells us the frequency. Oh, well, pulseout has resolution of a microsecond, which is megahertz. So our resolution is going to be a megahertz. So this must be clock divider of 80. And the other reason that this resolution hertz is the way to go is because, especially now that they have a lot more chips that they support, they have different clock frequencies that they run at. So by telling the IDF that we wanted a megahertz, like there's, it should work, it's more portable that way, rather than doing the clock division as the request. Okay, and then we're gonna need to do carrier frequency as well, which is, let's pull it up. RX carrier config, TX carrier config. So originally when I designed this API, you had to pick a PWM resource and you had to pick a PWM out that you passed into pulseout because that's under the hood how SAMD used it. But then this peripheral in the ESP chips kind of does it all on its own. So interesting. Duty cycle, carrier duty percent. Okay, that's is times 100. Oh, but now this is a float. So we want to make this a float. Carrier frequency is passed into us. Duty cycle is not important. Taya says, does this mean in 2024 we could have changing frequency while code was running? Like say battery and clock down, assuming you can't sleep, then back up to analyze something. We start to have that. So the RP2040 port actually does allow you to change frequency, but it tells you, it has the caveat that you have to, anything that you instantiate or create, you need to do after you've set the frequency. So it's like, and that's because like it's doing all under the hood, all this clock divisor stuff is happening. And if you change the like incoming clock, the divisor is not going to get updated automatically. So no, not really. Sleep is still your best bet. Unless you just wanted to always run it at slow speeds. Carrier should be modulated to high level. I think that's right. Carrier enable true. So like this config and driver stuff goes away. So I think we do need to do RMT enable self channel. And I haven't actually tested Neopixel, but I think that's true there too. Neopixel has this cool encoder thing. So the nice thing about the encoder is that you can convert individual bits to certain pulse values, which is really neat. And then RMT transmit is what we want. We're going to want that too. Copy. Let's copy all this. This is going to be the body of our pulse out. So now channel is going to be null when we're done with it. So we're going to do RMT del channel. And then we'll set it to null. Let me d'init. And then in here, we're not going to loop. We're going to have a low end of transmission level. I don't think we want a coder. We'll have to look. Self. And we'll just, we don't have any memory that we need to delete if this fails, so we can say check ESP result. Check ESP result is a macro that will raise an exception if it's not okay, which is very handy. And then wait all done we could actually make smarter, because this 100 is milliseconds to wait, I think. And we could actually compute that so that we know how long it should take if it's working. Oh, and you know what? Maybe we don't want wait all done, because run background tasks. So let's actually see what wait all done does. How is that documented? Timeout. Ah, so we don't actually want to use the timeout here. Otherwise, we won't run background tasks. So what we want is we want while wait all done is equal to ESP, what was it, error timeout? Like, so while it's timing out, that's fine. We'll run background tasks. And what we can actually do is we can do it this way. We can say esp error t result equals esp error timeout. And then we can run background tasks, call this. And it says forever timeout milliseconds has to be -1 to wait forever. So maybe if we give it 0, it won't wait, but it will tell us whether it's done. Result equals. And then we do esp check, error check, or check esp result. So we'll raise an exception if it's not okay. Otherwise, we're done. And we don't want to wait all done. And actually, did I delete that in Neopixel? Or do we want to run background tasks here as well? So you couldn't have Neopixels running and not skip a beat. You'd have to de-init and re-init. Not sure what you mean. But yes, the Neopixel write is a blocking call. So you can't do anything else while you're transmitting Neopixels. And this is the code that would block, is the wait all done here. But I think that's what I did. Oh, is that my bug? So I have big long strands of Neopixels around my front windows that I put up for the holidays. And there's issues where it like flicker. It's supposed to be white or red only, and it flickers to green sometimes. And I wonder if, I don't know how long it takes per bit, but I wonder if this wait tx all done is too low. Let me pull up merge and take a quick look at what the old implementation was. Neopixel write. It did all the conversion itself. And yeah, RMT wait TX done. So it waited 100 milliseconds with this blocking. So it wasn't running background tasks when it did that, which is probably a bad thing. So let's lift that pulse out check that I just did, and we'll put it in Neopixel write as well. So now we'll run background tasks while Neopixels are transmitting, which should be okay because yeah, it should be okay. We should be able to keep the RMT buffers full because we're not pushing it out here. So the RMT is going to have an interrupt that is like still going. So as long as the background task doesn't turn off all interrupts, it should be okay. Although run background tasks will run. Run background tasks will run flash writes. Probably. It's not the end of the world, I don't think. And in fact, what we can do here is say sorry, I'm just thinking through this. If result raise error. Trying to think if I can let it fall through. Yeah, think that's right. Okay. So let's go back to pulseOut. So it's allocated on the stack. Pulseout send allows 16-bit pulse values, while ESP only allows 15 bits. Thus, we use entire items for one pulse rather than switching inside each item. Interesting. Interesting. Because the other way that I did it in pulseIn is I just ran the output so it would have 2 microsecond resolution instead of 1 microsecond resolution. Which makes it interesting. So I wonder how it works with the encoder. Like, it has this encoder stuff to it that I found. The encoder I wanted for RMT encoder. Called multiple times. Like, it's just a duration. New copy encoder. All right, so this new bytes encoder, I did custom encoder. So I think what we want is this copy encoder. And we can do that in here as well. RMT new copy encoder. Encoder config and self encoder. So we'll do RMT encoder handle. We'll put that on our pulseOut object. It's interesting, they're called handles, but they're actually like pointers into their memory. I think the reason they're called handles is because they don't want you to look inside of them. Like, it's all internal state. Yeah, it's really interesting. I've been really interested in how they've done it. And I expect, copy this, that this is actually empty. I fat fingered it. Okay, I should probably turn my lights down. The sun went away, so like the ambient encoder config. Let's just click through here. Yeah, it's empty. It's an empty struct. It's interesting. New copy encoder. And then this is the annoying part, and if somebody has recommendations on how to, because they're doing memory allocations, you want to say if result is not equal to ESP OK, something's wrong and we can't go on. So we need to then do the like tear down stuff. So we need to say like RMT del channel, self channel, self channel is equal to null. And then raise ESP error result. So it's kind of annoying. There's a couple spots in here where it's like 3 different allocations I have to do, and every time you have to, if you fail it, you have to do that. Empty struct on the public side, but internal struct stuff is private. The empty struct for the copy encoder, I think, is actually empty. It's empty, because they have this comment that says, yeah. Wasn't I thought there was a, like, we're going to expand it in the future, even though it's empty right now. And so then when we do teardown, we also want to do RMT del encoder, which are we doing in Neopixel? No. I'm sure I'm not going to get this all right, but. Okay. Manual memory management. Okay, these are a little bright for me now. Yeah, see, that looks okay, and I'm not being blasted in the face with light now. Okay, so I didn't do the copy encoder. I could do a custom encoder. That could be kind of nice. Because I already have a buffer of pulses. It'd be neat if I could use it. Like, they're almost right. They're almost in the right format. I could destroy the buffer as I did it, but then now I can't modify that buffer, which is why this is a separate allocation here. Or if I do a custom encoder, they have an example for a custom encoder. If I did a custom encoder, I may not need to create that intermediate buffer. They might hand it to me. Where is that? RMT encoder. Some commonly used encoders are provided out of the box. They can either work alone or be chained together into a new encoder. Contains the following functions. Encode might be called multiple times within a single transaction. The encode function should return the state of the current encoding session. Supported states are listing in RMT encode state. If the result return contains RMT encoding mem full, the program needs to yield from the current session as there is no space to save more encoding artifacts. Battery I/O? Well, that's what alarm is. Like, alarm is doing. Reset should reset the encoder back to the initial state. This function is also called implicitly an RMT disable. And then del should free the resources allocated by the encoder. Customize RMT encoder. Okay, so how does this work? The base class declares the standard encoder interface. Instantiate two other encoders, leading symbols, and record the kernel state. Huh. Except they don't actually show how to call it. You get the encoder state, you get the channel, you get primary data and its data size, and then you get RMT encode state. How does it? I guess I don't know what encode state is. Return encoded symbols. It's returning a size. I don't know. I don't know. This is not clear to me. RMT one wire. Customize encoder for Neopixels. I wonder if that looks like my Neopixel example. Huh. Pi test LED strip. LED number of pixels. This encoder stuff is complicated. Like encoded symbols, bytes encoder. It's using a bytes encoder and a copy encoder again. Can I not actually make my own? New encoder. Ugh. Like, that is complicated. I think what I should do is just deal with it. Like, the current implementation allocates to the stack, I can do that too. So instead of RMT item 32, we're doing RMT value or something. Where would I find that? It is simple word. I think that if you had a zero length pulse, so Neopixels and remote control are similar. I didn't realize that. Yes. They're similar in the sense that 0 and 1s are encoded in pulse length. Right, so Neopixels, it's like a 800 kilohertz signal where a 0 is a third duty cycle and the 1 is 2/3 duty cycle, something like that. And then I think that like something very similar is for infrared remotes as well. The infrared remotes have this additional thing where they have a carrier frequency as well. So that's what the carrier thing is. Yeah. Okay, so setting the RMT duration to 0 has undefined behavior. I feel like if it's 0, we should just skip it. Like, continue. This is a weird. Is that because we can't? Do a initialization thing? Well, I don't know why there's 3. Like we can keep the. Like this is just duration 0 equals that. Level 0 equals that. RMT is useful for lots of stuff where you want to send or receive arbitrary pulse lengths. Right, so that's what pulseOut is doing. Pulseout is meant to be uncrust a file. This is kind of clever. So it's let's do it this way. Right. So this is saying like if the top bit is set, then also set this. Is that right? Yeah, I think that's right. Otherwise it's 1. Because you can't give it 0. Right. Neopixel is like 3 bits per bit, a start and end bit with a value in between. Right. Yeah, so that's the 1/3, 2/3. A lot of our implementations use actually disable interrupts and just bang it out. Because the problem with using PWM or SPI is that you really limit the pins that you can do it on. The nice thing about the ESP is that the RMT is connected through that like full mux. So as long as you have the resources available, you can do it. Yeah, level 1, thank you. Right, so this is putting half at the front and then the remainder at the back. And that's okay. Since we're waiting for it to all be done, then it's okay that it's in, like the stack is going to be in internal memory, which is what we want. And num bytes is going to be the length times the size of that. Transmit channel encoder. Yeah, that's fine. Self encoder, self channel. Symbols. Length times the size of a symbol. Give it the transmit config. Return to 0. I think that's what we want. Okay, let's see if it compiles. Which it probably won't. I always do that. All right, we got about 20 more minutes. Any folks have questions? I know I've like gone into the weeds here. Neopixel problem. The two levels are 0 and 1 usually, but we're hacking it so it's not. So the RMT gives you 15 bits of resolution, and you can get 16 if you use 2 sessions of. If you use 2 segments of a symbol for the same value, then you can get 16 bits out of it. Sleep tight, David. No problem. And you know, if we really wanted to be precise, we could have it subtract 1 if... Let's see, these are down to the microsecond. The same level was intentional, and I didn't come up with that. That's what the existing code did. Like I just see that is one thing, is like the APIs are going to be super different because the underlying hardware is the same. So like they rename things, but ultimately like it works pretty similarly. So yeah, yeah, there's a comment that's already here. It says while ESP only allows 15 bits for 1 pulse, we just use 2. Each symbol has a level 0 and a level 1. And there's a bit in there that says whether it's high or low. So you can just use 2, like the 2 things within a single symbol word to do the same level. Right, and wait to finish. Okay. All right, so we're in pulseout, but it's not seeing that these things are declared. So I think I'm just missing some. Includes. Like include bindings esp-idf init h, that has the check macro, and then include driver rmt tx.h. Good night, Dishipu. It's a great deep dive for sure. I'm glad I found my audience. Hey, we have less than a page of results. And it's not ESP result, it's ESP error. 49. I always do that. I always call it result, but type is error. Expected expression before token. So yeah, I think this is what unused variable level. Right, so that's a fluke. So when you're doing error messages, you usually want to do the first one because it can cause subsequent error message issues. So if we you know what, this doesn't mean that you can do a full duty cycle. Like, it's all these corner cases where it's like, it would be good to have them like written down and documented. Oh, what was I fixing? This instantiation thing. Yeah, so I think that it might be like a C-ism. If we can say, like the when you can provide this instantiation, maybe that'll work. Because now we've told it what type it is. Yeah. Okay, 102, it's not size, it's size of. You know, small things like that. Oh, you know what? I thought about even yesterday, I was like, I gotta find my rotary encoder so I can test things today. And I haven't. Ugh. It'd be nice to test without the carrier. Okay, so it compiled and then it errored out because I don't have the test board in bootloader mode, which is good. Now it's on to testing, which getting me to thoroughly test things is like getting me to pull teeth. So, and it's Friday afternoon. Mark says my new order of dual rotary encoders showed up this morning. Nice. I think I might procrastinate on testing this all until next week. I do think that, like, if duty cycle is equal to 0x f, then do it. Atom text editor. Nope, this is Sublime Text. I find it. I tried Atom ages ago, and I tried VS Code, but I found them pretty slow. So I paid for Sublime Text. It's not that much, and it is. Did you just say rotary encodery? Probably. That sounds like something my toddler would say. Duty cycle is not. So this is saying that, like, if you're at the highest, like, 16-bit duty cycle, then it'll be solid. And I don't know if we document that. I was looking at the pulseIO docs again, and I was like, this is not very explicit. Maybe that's what I should do right now. Is just write that up as a, yeah, maybe that's what I'll do. So like pulseIO doesn't tell you that its base unit is microseconds. PulseIn doesn't tell you what happens. Oh, it does. When there is no room, the oldest pulse length is removed. Somebody filed an issue to change this, and I agree with them. Because the oldest pulse length is, it doesn't make any sense. Because then you, like, we don't tell you, wait, does it make sense? No, we don't tell you, like, so the structure that you get from the RMT is you get duration and level. But in pulseIn, we don't tell you level. So if we have this behavior where we overwrite the oldest, that means that when you get the next value, you'll have skipped one, and now your polarity is wrong if you're keeping track of it. So that's just like something I want to change. Like, it's just bad behavior because like you'll be all out of sync once you do that. So when there is no more room, length equals max length. Any newer pulses. What is the term? Is paused, and any other incoming pulses are ignored. Okay, that's a breaking change potentially, but it makes so much more sense. Pause pulse capture. Resume. In microseconds. When length is equal to max length, it is unclear which pulses are active and which are idle. Okay, so that's like a functional thing. Or an error during capture, such as a signal that is too fast. Okay. So this is a case where we're going to have to like audit. Oh, I have a question for folks who are still watching. Do you ever use the context manager? So like with pulseio.pulseIn as pulseIn, and then like nest everything? Because I was thinking we could probably save a non-trivial chunk of code by just deleting the enter and exit ones, which are the things that make it happen. I might, you know what? I'm going to put this in the weeds for next week. Like, we're already in betas for 9.0, but this is sort of thing that could get us some space back. And I don't think anybody uses it. Like, people will use dinit, but they don't really use the context manager. Jeff, yes, you mentioned last week that you got laid off. I'm sorry to hear that. And I don't think the Adafruit jobs board is going right now. But feel free to like post a little blurb about what your experience is and what you're looking for in the Discord server, in case somebody else has knows of some positions open. So yeah, let me click off here just for a bit. Let me pull up the notes for next week. So I went into the CircuitPython dev channel and I clicked the meeting notes. So I want to do in the weeds. Remove context manager functionality of core classes. Something like I don't want another bullet point. With pulseIO. Oh, come on. Just with pulseIO. pulseIn blah, 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 blah as p dot whatever. And then calls dinit automatically. Unset. Oh, look at that. That way it detected that I was doing a code block. I have like the markdown thing. Neat. That's pretty cool. Wow, that did not make sense. I guess I gotta use tabs. In the Weeds is part of the CircuitPython Monday meeting. Yes, that's a good chance to talk about that. So we have a weekly meeting. It is Mondays at 11 a.m. Pacific, 2 p.m. Eastern. It's in 5 sections. We have community news, state of CircuitPython libraries in Blinka, which is a bunch of numbers dump. Hug reports. So thanks. It's like a chance to say thank you for other folks. And then status updates is what you've been working on in the previous week, what you're working on in the coming week. And then in the weeds is a longer form section for any sort of discussion. And this kind of like, I need to ask a bunch of people, can I remove this? Is a perfect place for that. Moving it would save, enter, and exit entries in locals dix and the corresponding function. I don't think anybody uses this. I was meaning to look through. I think it's used, like the bus device has a similar pattern and it's used there for transactions, but I don't think it's actually used in practice for a lot of the stuff. So removing that could simplify things and kind of like, yeah, give us more code space and simplify the reality of like nobody does that. So yeah, if you have any comments, what you could do is you can go into this notes doc. So to find the notes doc, if you go into the CircuitPython dev channel on Discord, which you can join by going to the URL adafru.it/discord, hit CircuitPython dev, and then at the top hit the pin, like the push pin icon, and it's pinned there. And so when we do a meeting, after the meeting, the host of that meeting creates a doc for the next week's. So you can collect like hug reports and status updates ahead of time if you want. If you're unable to make the meeting, you can still give hug reports and status updates. Just in here, you can say like, I don't know why it's there. Like you could say like your username and text only is one thing we say, but like add a note there that like you want it read off, like please read. So and then the host will read your updates there. And feel free to put notes down here as well. It should be open so folks can add comments and stuff. Yeah, so that was a brain thing. I think, actually, you know, maybe I'll just add my notes about updating pulseIO frequency rotary IO. What did I say? Count IO and Neopixel, right, to IDF5 APIs in order to fix bugs and move to APIs. pulseIn will be switched, pausing reception, receiving when full. I wonder, isn't it with pulseIO I2C used for drivers though, like sensors? Seems not totally unused with pulseIO. Ooh, here we go, yes. Oh, okay, so it is used. Huh. I mean, we can run all these down, but yeah, that seems like a good reason for probably not. Okay. I'm going to add that to the notes. Or Tyeth, you're welcome to add it to the notes too. I'll give you credit for it. To remove all of them. Like we could do it in a limited fashion. With is normally just a context for not having to type as much, plus maybe lock resources. Yeah, so the with context, it's used to deinitialize the, like it's, because these native classes tend to grab resources like particular peripherals, the with box like will automatically deinit when you exit it. So that is how we're using it. Kind of hate this. Yeah, it's a nicer try family. Huh. And Yanni's pointing out a WebAssembly for microcontroller thing. That is way out of my wheelhouse, but somebody might be interested in it. All right, well, it's 4 o'clock. I was gonna go for a run before finishing up. So thank you all for hanging out. I will commit my changes and I'm going to procrastinate on the testing part until next week. But I think I do want to get back to that guide and get it released, because I think there's a bunch of useful stuff in there. And I'll come up with a plan on how to do that without having to have everything complete. Maybe I'll just go over what I've written and publish it and then say this will be updated. So come back and check. I do kind of want to run the performance numbers again, because we've updated MicroPython since then. Anyway, yeah, the good advertisement for the weekly meeting as well. Thank you all for joining me. If you missed the intro, my name is Scott. I go by TanNewt online, and I work for Adafruit on CircuitPython. Adafruit pays me to work on CircuitPython, so if you want to support me and them, or if you want to support me, do it by paying them. So go to adafruit.com, purchasing some hardware. That's lots of cool stuff. And learn.adafruit.com has a learn.adafruit.com has examples that you could find for projects that you want to do. If you want to join the Discord, I'll give the URL again, adafru.it/discord. I do these deep dives 2 p.m. Pacific, typically every Friday, but I have a toddler and things come up, so Foamy Guy fills in for me, so thanks to Foamy Guy as always. DCD has one last question, which is, do guides take pull requests? And the answer is no. I did try to convince the other Adafruit folks that we should like store all the data on GitHub so that people can do pull requests. I wonder if that's the reason enough to move it out of a guide, honestly. That would be another way to collaborate where I don't have to do it myself. So I'll run that past Lamore and see what she says. But generally, like, she likes guides. Like, guides are the thing. So maybe we could just do a placeholder or something. But yeah, I think I would, because I'm so bad at testing, it would help me to have somebody to collaborate with, and it's going to be easier to collaborate on pull requests, especially if like other implementers come along and have tweaks to it. That could be more useful too. So yeah, not currently, probably not in the future. Although if there's a lot of stuff you want to be involved in, we can get you a Learn account as well. Yeah, food for thought. Maybe I'll talk to the internal folks next week as well, if I remember. Yeah, other than that, I think normal schedule next week. Yeah, keeping the guide up to date. Well, if you've looked at the debugging with GDB guide, it's not up to date either, and that's another one I wrote. The extending CircuitPython one is out of date, unfortunately too. So if you're interested in doing that and you say, if it was in GitHub, I would do that, then that would be super helpful too. All right, I think that's it. So thank you all. I'll see you next week. Support Adafruit, adafruit.com. Join the Discord, adafruit.it/discord. Try CircuitPython if you haven't. Come to the weekly meeting if you haven't, and you can on Mondays. Otherwise, we'll see you on the Discords. And